means, please do so. First thing we're going to talk about is factoring. There are rules from factoring that you learn from Algebra 1 and Algebra 2. And the rules from factoring is, first there's mental factoring. And with mental factoring, it's if you have the format x squared plus bx plus c. Okay? What that means is that your leading coefficient is a 1. So all you focus on is c and b. So what you're saying is what factors multiply to give you c, but also add to give you your b. Once you find those factors, you plug them into the binomial. Okay? So for example, if I had x squared plus 6x plus 8, I'm going to look at 8 and say what factors multiply to give me 8, but also add to give me 6. In this case, it would be 4 and 2. I don't know what happened. Excuse me. So 4 times 2 is 8, and 4 plus 2 is 6. So therefore, my factors are x plus 2 and x plus 4. You all remember that from Algebra 1?
Yes.
Okay. Moving on, in Algebra 1 and Algebra 2, you learn about the cab and Punnett. I think that's how you spell Punnett. I hope I spelled Punnett right. So you learn about the cab and Punnett square, or how to use the quadratic. So the reason why you use these two is if you're in the format of ax squared plus bx plus c. And what that means is that there's a value for your a that's greater than 1. And it's called cab. With cab, you're going to take c and times it to a, and you're going to leave b alone. And you want to know what multiplies to give you c times a, but adds to give you your b. Once you find those factors, then you plug them into the box, and you use GCF to solve around it. Okay, so for example, if I had 2x squared plus 7x plus 6, the first part of cab is to multiply c times a. c is 6, and a is 2x squared. So 6 times 2x squared gives me 12x squared. We agree, Nikki?
Yes.
Okay, and my b term is 7x. So what multiplies to give me 12x squared, but adds to give me 7x? 3 and 4. 3x times 4x is 12x squared. 3x plus 4x is 7x. So those are my factors. That's my F1 and my F2 that go in my box.
So cab is going to save this one?
Huh?
I said so cab is going to save this one.
Yeah. So then when I get here, is greatest common factor. What's the greatest common factor in the first row? That would be 2x. What's the greatest common factor in the second row? That would be 3. What's the greatest common factor in the first column? X. And what's the greatest common factor in the second column? That would be a 2. So therefore your factors are 2x plus 3 and x plus 2. So that's using cab and Punnett. Now, or if you're more of a computational person, you can use the quadratic formula, the quadratic equation, I'm sorry, and the quadratic formula, function, formula, one of the two. Here you go, you have x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, do y'all remember that?
Yes.
Okay, that's where you take your a, your b, and your c, and you plug it into the function, the formula. Okay, so you take it and plug it into the quadratic formula, and by the time you get through plugging in, you're going to end up with x equals negative 2 and x equals negative 3 divided by 2. What this means is that if it's x equals negative 2, that means you actually have x plus 2 as a factor. If you end up with x equals negative 3 halves, what that means is your denominator is your leading coefficient of the other binomial, and instead of a negative 3, it is a positive 3. So either way, you're going to end up with the same answer of 2x plus 3 times x plus 2. Whichever way you're more comfortable with, and whichever method you learn the most or more familiar with. If you would like to review these methods, you can come to tutorials and we can discuss these methods. So, any questions about these two? All right, we're going to move on. The other methods are in Algebra 1, you should have learned difference of squares. Difference of squares is saying if you have a squared minus b squared, If you have a squared minus b squared, it can break down to a minus b times a plus b. Okay? The way you get your a is you take the square root of your a squared. The way you get your b is you take the square root of your b squared. So for example, I have 4x squared minus 9, right? What's the square root of 4x squared? 2x. What's the square root of 9? 3. So now I can plug them into the binomials. I have 2x minus 3 times 2x plus 3.
So if it was 4x squared plus 9, it would be 2x.
You couldn't do that. There's no sum of squares. Squares.
So only if it's minus.
That's why it's called difference.
Yeah.
All right. So then our next one is difference slash sum of cubes. So I have a cubed minus b cubed, and the rule is I have a minus b times a squared plus ab plus b squared. That's for difference. And for sum, I have a cubed plus b cubed, which is a plus b times a squared minus ab plus b squared.
What does that?
Excuse me?
SAWAMES?
Difference of squares?
Oh, okay. Thanks.
It's difference of squares. I forgot to write it at the top, so I had to squiggle it in somewhere. Okay, so for example, if I have x cubed minus 8, well, to find your a and your b, you're going to take the cube root of each term. The cube root of x cubed is x, and that's because it's x times x times x, right? The cube root of 8 is 2. That's because it's 2 times 2 times 2 will give me 8. And once I have those values, then I plug them into the rule. So now I have x minus 2 times x squared plus 2x plus 2 squared, which is 4. Okay, we reviewed this stuff for like 2 weeks, 3 weeks almost in the beginning of the year. When I gave you I gave you a factor guide. It was like page maybe 4 or 5 in our first semester journal. If you still haven't, if you need to review that factor guide, just pull out your first semester interactive notebook and you can see it there. If for some reason you discarded that, you have new notes now. So, in that, you just have more examples and more practice problems. All right, last is grouping. And grouping is where you combine the first 2 terms and the last 2 terms. And once you combine them, then you find their GCF. So looking at the first 2 terms, their GCF would be x squared, right? So when I factor out x squared, I'm left with x plus 1. Looking at the last 2 terms, their GCF is just a 1. And when I factor out, I'm still left with x plus 1. So now between this term and this term, their GCF is x plus 1. And I'm left with x squared plus 1. And so that's how you factor by grouping. The reason why we need to review these skills is because we're doing long division, and we want to put our answers into factored form. So just to make sure you remember some of those rules, kind of needed to know. Are there any questions over what we've done before we get started on our notes? All right, let's get started on our notes, and at the end of the class, if we have some time remaining, we'll talk about some of the questions from the quiz. Okay, so starting off with, we have long division to determine the given polynomial is a factor. Well, back when I was in high school, my teacher was a big person on basically guess and check. We had to figure out what factors work, and then we would have to do long division. And then you test the long division, and if it goes in there evenly, then woo, you found one factor. Okay, and then you would go on again. Okay, basically you're kind of doing the same thing, except I'm giving you a factor to test. I'm saying, let's try x plus 4. Is it a factor of this problem? Well, for example, if I said, is 4 a factor of 24, what would you do to prove to me that it is? You would do what? You would divide, okay? You would divide because you prove something is a factor by division. So I have 24 divided by 4, which would give me 6, which proves that 4 went into 24 evenly, and therefore it is a factor. So that's what we're trying to prove here, is that is x plus 4 a factor? Well, before you do anything, you need to make sure that your polynomials are in decreasing order. So I have x cubed, x squared, x, and no x, right? So I'm in order, I'm ready to go, and so let's start dividing. So when I divide, I have my big polynomial, my whole polynomial goes inside. And the factor you're trying to prove goes on the outside. So I'm trying to prove that x plus 4 is a factor. Okay, so by doing this, what you're focusing on is the leading terms. So in this problem, my leading term is x, and this problem is x cubed, right? So my question is, how can I take x and turn it into x cubed through multiplication?
Write it 3 times.
No, through multiplication.
Times by 3.
No.
Divide by x.
Multiply by x squared.
Thank you, Don. Multiply by x squared.
Wait.
Okay? The reason why is because if you look at your rules for exponents, you actually add them. Remember, you add exponents. So if I have 1x here, how many x's do I need to make it into x3? I need 2,
Okay.
so it's x squared. Okay? So once you have that, just like you would do long division, regular long division, I'm going to multiply this to my outside number. Okay? Let's look at a long division problem. Someone said what? Let's look at a long division problem. So looking at this long division problem, I have 4, and I'm going to divide it into 21, right? How many times does it go in there?
3, 5.
5. So then I do 4 times 5 on the side, right?
Okay, now it makes sense.
And then I do 20, and then I bring down the 1, and then I bring down the 4. 4 goes into 14. How many times?
3.
So in my head, I do 4 times 3, which gives me 12. Then I subtract, get 2, bring down the 6. Then I'm like, okay, 4 goes into 26, 6 times. 4 times 6 is 24. Don't worry, people have asked me. That's why we have this example ready to go. So, do you see why I'm doing this on the side?
Yes.
Because whatever I write up here, that means that these need to multiply to help me get to the next step. Does that clarify a little bit?
So do we need to have that on the side?
No. If you can do it in your head and work through it, that's fine.
Oh,
Just in case you mess up, you could
Okay.
look at yourself.
Because this is a binomial, I'm not only multiplying x squared to the first term, but also the second term, because they are together. So I have x squared times x, which will give me my x cubed. But I also have x squared times 4, which gives me 4x squared. Just like we were doing, you're subtracting. When you subtract, that means you're changing the signs of everything. So instead of this being a positive x cubed, it's going to become a, instead of this being a positive 4x squared, it's going to become a negative. So x cubed minus x cubed, and then 10 plus negative 4x squared is,
6x.
and I'm going to bring down my next term. And then I start the process over again. So again, I'm only worried about the leading term. So the leading term here is 6x squared. So how can x become 6x squared?
6x.
I need to times by a positive 6x, right? So I'm going to do 6x times x plus 4 in my head or on the side. And when I FOIL that, when I distribute that, I get 6x squared
Plus 4.
plus 24x. Because 6 times 4 is 24. Again, I'm subtracting. So subtract, subtract. What happens here? And what's 32x minus 24x? I get 8x. Bring down my next one. Okay? So now I'm going to look at this leading term. So how can I make x into 8x?
times 8. I mean, plus 8.
It's going to times 8, so I need to add that 8 on. So now I have 8 times x plus 4, and I'm going to end up with,
8x plus 32.
and when I change all the signs, what's going to happen?
It's going to be
I end in 0, so that means that this is a factor of this problem, right? Because it's a factor, now it wants me to write the result in completely factored form. When it says completely factored, so I'm going to take x plus 4 times x squared plus 6x plus 8. Can I factor?
Yes.
How can I factor my numerator?
Pi squared.
Well, how can I factor this trinomial?
Cap. Oh.
Can I use mental? Because my leading coefficient is a 1. So I have x plus 4. And what does that factor out? We actually did that one in our notes.
Yeah, x plus 2 and x plus 4.
So this becomes x plus 4 squared times x plus 2. And that means that the full factored form of this long polynomial is this. Now that I'm in this factored form, can I now graph my problem?
Yes.
Can I identify my x-intercepts?
Yes.
Ms. Jones, would you? Next.
Yeah, which
There's 2x.
There's 2x plus 4s. How was it?
I feel like we should do it.
Yeah.
We are. But was it really that bad?
No.
Yeah. All right. All right. All we're doing is division. What you learned in 3rd grade is what we're doing.
The last part of the division problem is supposed to be negative.
Right here. I just didn't change the signs because I knew it would cancel out. I just didn't change the signs, but yes, technically they would both become negative. All right, so I have x to the, now, again, I gotta check and make sure that that it's in decreasing order and all powers are represented. So when I look here, do we have a problem with 2?
Yes, no.
Are all powers represented?
No.
No, we're not. What's missing here?
Oh.
It goes 5, 3. What's missing between 5 and 3? 4. So that means you have to add a 0x to the 4. Why do I add a 0x to the 4th and not just an x to the 4?
Because it's non-existent, so it has to be set to 0.
Exactly. It's non-existing and 0 won't change the value of my polynomial. However, x to the 4th will change that value. Okay? It's just like saying, oh, guess what? I like you so much, Yvonne. I'm going to go deposit $0 into your bank account. That's how much I like you. Okay? What did I just tell him?
You didn't give me nothing.
I'm not giving you anything. But I'm like, you know what, Javon? Good job at that relay this weekend. I'm going to go deposit $1 into your bank account. What does that tell you? I gave him $1. I'm changing the value of his account. But that 0 will not change that value. Okay? So that's why it's a 0x to the 4th. All right, so 5, 4, 3, 2,
1.
what's missing?
1 plus 0x.
Plus 0x.
I can't get out of my bag.
Okay, so now I'm ready to go ahead and go inside of my division.
So you're going to put
5x to the 5th plus 0x to the 4th minus 3x cubed plus 8x squared plus 0x minus 24.
So we don't factor out the parentheses, we just leave it.
What parentheses?
Well, like these, like at the
That's the factor we're trying to prove.
yeah, so you got to put that in the front.
So this goes on the outside.
Okay, well I just didn't know if we, I don't know why you would.
All right, now this is my disclaimer. Sometimes adding the zeros will not make a difference in how you work the problem. Okay? But you're going to do it just for practice because there are times when it will make a difference in how you work your problem. Does that make sense?
Yeah.
All right, so don't, like, Miss, we didn't even need that. I disclaimed it already in the beginning. All right, so start again. I'm focusing here and here. So how can I take x squared and make it to x to the 5th? Plus x cubed. So I'm going to take x cubed, times it out over here. And what happens?
And you bring down the.
Do I have a 4th there? Again, that 0 is a filler, right? All right, so when I subtract, it's going to do what to all my signs?
Make it switch the negative positive.
So if I have a positive, it's going to become a negative, and if I have a negative, it's going to become a... And what happens to everything? Everything goes away. Okay, since everything went away, that's cool, we're alright. We're just gonna bring down the rest.
8x squared.
So I'm gonna bring down everything else. So I have 8x squared plus 0x minus 24. Again, what am I focusing on? The first term. So how can I take x squared and change it into 8x squared?
4x.
I'm gonna add 8.
Okay.
I already have the square. The only thing I'm missing is the
I'm times 8.
8. So I have 8 times x squared minus 3. So 8 times x squared is going to give me, I'm not going to end up with a 0x. And 8 times negative 3 is negative 24. Change the signs of everything. And everything cancels out. So am I done? Yes. I identified my factors.
X cubed.
So my factors are x squared minus 3 times x cubed minus 8. Is it fully factored?
Well,
Plus 3. I just said plus 3.
Plus 8.
Plus 8. Plus there. You know what I'm plus and plus it. Alright. What do I do?
add them together.
What?
Add them together.
You factor.
I'm trying to.
Sum of
Different.
cubes. The sum of cubes. This one's fine, but the second one is not. And sum of cube tells me here my a equals x and my b equals what? 2, right? My b equals 2 because the cube root of 8 is 2. Y'all wonder why we had those in our notes? Look at your notes we just went over.
No, I'm not talking about
X
that.
minus 2, x squared plus 2x plus 4.
I mean, I'm not confused, but I feel like there's potential for me to be confused soon. Does that make sense?
No. All right. All we did, guys, we divided. Did I lose anyone on the division?
So yes, when there is a 0,
Okay.
do we just do we just like skip over it?
Where there's a 0, we just kind of put another placeholder there. But if it comes, like when we come here, you'll see how it actually comes into part. So the 0 will be utilized on problem 3, but we have to get used to plugging it in. And so when you don't use something in between, then you plug in a 0. It's acting as a placeholder. Okay. Any other questions on the division part? Okay, on the factoring part, we ended up with x squared minus 3 and x cubed plus 8, right? And because we ended up with these terms, that means it's sum of cubes. And with sum of cubes, that means we need to identify our a and identify our b. Our a is x and our b is 2. And all I did was take those values and plug them into the formula we wrote down. So if it's sum of cubes, the formula is a plus b times a squared minus a times b plus b squared. That is all I did. And now it's fully factored. Okay? If it had been difference of cubes, then I would have used this one. But because it was sum of cubes, then I used the second one. All I did was plug in that value.
So the 2 because the square root of 4
Because the cube root of 8 is 2. Because 2 times 2 times 2 is 8. So my cube root of 8 is 2. Any other questions? Yes, Don.
So if it's difference of cubes, we'll use that other formula?
Yes, Don. It's okay. I'm
Used to not being listened to.
pretty much.
It's okay.
All right, any other questions before we do the last one? Okay, this is going to be our last problem for today. What you're going to do tomorrow is going to be an all classwork day. You'll have 6 problems where you're going to factor them and graph them and identify their x and y intercepts. So we're tying in what we did last week onto long division. Okay? Yes.
We possibly can eat that today, because I'm going to be going tomorrow on a trip.
Oh my gosh,
No.
I'm gonna be done tomorrow too.
Well, if you come back after 6th period.
About 6%.
Where?
Yeah.
Oh, okay. I was about to say we're not coming back till 6.
No, if you come after 6th period today, I should have the copies made. All right. Any other questions? All right. Let's do this last one. We have plenty of time to do it. Shouldn't take us the whole time. So I'm going to check the order. I have 4, 3. What's missing?
2.
2. So I'm going to need a x squared in there.
So plus 0.
Okay. So I'm ready to divide. So, sorry, that looks like a square root symbol. It's not. So I have 4x to the 4 minus 2x cubed plus 0x squared minus 3x minus 9. And I want to test to see if 2x minus 3 is a factor.
Okay. Would it be 2x squared?
Would it be 2x cubed?
Yeah.
Cubed, not squared.
But yeah, because it's already
Okay?
a 1.
So I need a 2.
2x.
And I already have 1x, but I need 4 x's, so I'm going to have 2x cubed. So I have 2x cubed, so y'all can see what I'm doing on the side, times 2x minus 3. Okay? So I have 2x cubed times 2x is 4x to the 4. And then I have 2x cubed times negative 3, which gives me negative 6x cubed. Change my sign. And what happens here?
It crosses out.
And now I have negative 2 plus 6x is
4x cubed.
4x cubed. Bring down my 0x squared and start the process again.
Plus 0x squared minus 3.
So I need to change 2x into 4x cubed. So how can I make a 2 into a 4?
2x.
And I already have 1x, but I need 2 more, so it's 2x squared. So I'm going to do 2x squared times 2x minus 3. And I'm going to end up with 4x cubed minus 6x squared. So you see how our filler came into play in this one?
Just going to cancel that out. Make it 6x.
So now I have 6x squared.
Could be a negative.
I'm going to change the signs. It's going to become a positive. And I have 0 plus 6x squared is. And now I'm going to bring down my 3x. My minus 3x. And when I bring down my minus 3x, how can I take 2x and make it into 6x squared?
3x.
So I'm going to add 3x. I don't need a square because I already have 1x.
Oh, okay.
And I only need 2. So I only need 1 more. So over here I'm going to take 3x and times it by 2x minus 3. Again, this is what you're thinking in your head. This is your thought process. But if you need to write it out, there's no problem or no shame in writing it out. Okay? So I have 6x squared minus 9x. I'm going to subtract. So when I subtract, that changes my sign. And now I have 6x.
Minus 9.
And I'm going to bring down my last term. So now I need to know 6x, 2x to 6x. Plus just 3, right? I have the right amount of x's. I just do not have the right multiple. So plus 3, just to check, it'll be 3 times 2x minus 3, which will give me 6x minus 9. And I would change my signs and everything would do what?
Cancel out.
And everything will cancel out. All right, so now I have my factors. So I can write out my factor. So 2x minus 3, is it a factor? Why, yes, it is. It's a factor because what goes with it?
2x plus 2x. 2x squared.
2x cubed
2x cubed plus 2x squared. God damn.
plus what?
Plus 3x.
Plus 3x.
Plus 3x plus 3.
Okay. Is everything fully factored? How can I factor a 4 terms? 4 terms can be factored by grouping.
Group the first two and then the
Yes.
last two.
I thought we got 2x squared plus 2x. That's what I got on top of my things. Okay.
No, we have 2x cubed plus 2x squared.
Alright.
So by grouping, I group the first two
And the last two.
and the last two. So looking at the first two, what's their GCF?
2x.
2x squared. And when I factor out 2x squared, I'm left with
X
plus 1.
yeah.
Okay, what's their GCF?
3, I mean,
And when I divide out 3, 3x divided by 3 leaves me with an x. And 3 divided by 3 is a... Okay, so now when I factor this out, I'm left with
6x.
and now I can bring down what I already have. So my full factor is...
Wouldn't it be a square, outside of the x plus 1 because it's 2 of them?
No, they're being added together. So I'm factoring them out, and when I factor them out, only one comes out.
Square.
I get it, just a steps that just, forget me.
It's like
A chest of meatballs.
I'm feeling like we're gonna need to put the division for it's like
Yeah,
I didn't even begin to put that at the
that's
top
why it's called division.
today. I'm saying without the shut up, Miss Burke. You know what?
Man, I get it. I just know that you I'm missing, man.
Are we done?
That is it. We have time to go over our quiz. So if you did not take the quiz on Thursday, I'm going to ask you to step into the hallway